Hello! Today we're going to be taking a look at the parallax depth node. So you can see that right now with traditional parallax occlusion mapping, we get this nice depth offset here. But you can see there's a little bit of an issue, and that is as I move it out, you can actually see that the inside of these little columns gets brighter. They get white on the inside. And the reason for that is because what we're doing is we're taking the noise output value and piping it directly into the color. So we take the noise value and just stick it straight into color after an unbalance and vectorize so that it can actually read it as a color. But that means that as it starts to see the inside, because the layers will start to spread apart, it's still whiter on the inside, which is a little bit of an issue. So instead of piping the value of the noise into whatever algorithm you're using to generate your color, instead you can use the parallax depth value with an inversion if you want the same value as the noise. And what this will do is this will give you the direct value of the layer itself. So this is the second layer, and the entire second layer is going to have that value. So now we don't have that strange dark halo effect. So if you see the old one, looks like this strange look to it. And it's got this brightness even down into the depths. Whereas with the parallax depth, this effect doesn't happen. And more importantly, the reason that parallax depth was created is now, I'm going to move this out of the way. Now you can do things that are a little bit more complicated with the occlusion mapping. For example, piping the parallax depth into the noise function itself. So if you imagine, instead of having it cast a ray directly down onto the surface, what you're doing is as it casts it, as it goes down each layer, you're not just checking the height itself, but you're also checking with the 3D value of the noise on whether or not it's hit something in the third dimension, not just a 2D color. To do this, what we're going to need to do is actually have it take this parallax depth value along with the texture coordinate. Now the text coord is a 2D vector that goes left and right and up and down, but what we need is also the in and out, which is where the parallax depth comes in. So what we can do for this effect is actually after we multiply this, well, actually, we'll put this after it. And what we're going to do is we're actually going to break this vector, break the texture coordinate here, and then make a vector 3. So we're breaking apart the texture coordinates into its x and y value, and we're just going to plug those directly into here. And we're going to take the parallax depth, stick it in here, and now we've made a three-dimensional vector taking both the texture coordinate and the parallax depth, and we'll just put that in the multiply, and we'll see what happens. So immediately you can see that we get this sort of camouflage looking stuff. But you can see that it is actually 3D. There are objects floating on top of other objects. So if I just maybe lower this down a little bit, you can see down here, I can't really show you with my mouse because the view direction is determined by the mouse. You can see there's this sort of overhang. I'm going to stick that back up again, maybe to here. And then if we lower the depth, possibly it'll look a little bit better. So we don't need a complex. Now, a noise depth is not the same thing as the parallax depth. The noise depth is just how grainy, the granularity, the graininess of it. So if I set this to 10, you can see it's super granular. But that's also a lot of computational expense on the GPU. So that's not really a good thing. But if I set it to 1, you get these really simple shapes. And you can see they are floating on top of each other. I want to make this look a little bit nicer. What I'm actually doing is I'm just throwing the noise value directly into the parallax depth, which is kind of a difficult way to visualize what's happening here, because if I just take this value and put it here, then we get the standard just up and down values without any three-dimensional things put into play. But basically what's happening with this is as it goes down each layer, it's just checking the height, and it's going, okay, am I below the value? 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 As you put that in. But with the noise, with the 3D value at the parallax depth, what it's doing is as it goes down, it's actually checking. So you can actually have it go underneath the noise, right? So if you see this little blob here that I'm circling with my mouse, if you can see my mouse, if I pull the view back, you can see that there are rays that are actually going underneath that, and that's because as it goes down, it hasn't hit that 3D value. And this value only comes from the simple height value, the depth being less than the value of the noise. So maybe a little bit of an easier way to imagine this is if I make a if statement and I just say if this is less than 0.5, put that there, and then put another float, and we'll just make this a 1 value, and then we'll take another float and we'll just make it 0, and we'll just pipe these values in, put that in there, and then here's what we get. You get these little columns here. If I lower this, I raise it, make it a little bit easier to see it. There you can see. So now it's not doing things in the background. But basically now what it's doing is as it draws its ray, it's always encountering the noise. It's always going to hit the noise. Every single time as the ray progresses, it's always hitting the noise. But what it's doing is it's checking, is this noise value greater than, in this case, 0.8? And if so, then return this 1 value, otherwise return 0. But that's not the height value, that is the color. So what it's doing is no matter what the height is, no matter how far we are in the depth pass, a 1 will always make it return, well, white, although it gets gray as it goes back because of the color thing I have here. But if I return 0, it will always be, well, won't necessarily mean black, but that means that it hasn't hit anything yet. So it'll just keep going until it hits a 1. Now, if we just pipe this directly in without doing that if statement, what's happening is it's actually getting more and more dense because it gets more and more and more likely that it's going to hit the noise, because basically it's making the noise effectively thicker. As it goes down, that number, the depth value gets lower and lower and lower and lower. So the odds that it's lower than the noise increases. So that's why you see little tiny blobs up close, and then far away it gets really large. It's almost solid. Actually, after 0, it is completely solid. But that is the parallax depth node. Thanks for watching.